Hello, this is Mrs. Boots, and we're going to work our practice problems for solving systems of inequalities. So we have our first system on problem number 1, and I noticed that the y-intercept is at -2. So I'm going to go to -2 and put a little dot. Now remember, our slope is -5/2, so we would go down 5 and right 2, and then we can go up 5 and left 2. Now because it's an inequality, we have to figure out which kind of line we're going to draw. Because it has the equal to symbol on our inequality symbol, we are going to draw a nice solid line. Okay? If it did not have the equal to, then we would draw a dashed line. Now which way do we shade? Since it's less than, I have to shade where the bottom of the y-axis is. So we would actually shade all along in here. Okay? That is our first line. Now let's do the second one. On our second inequality, the y-intercept is at +2, and our slope is -1/2. So we're going to go down 1, right 2, down 1, right 2. Draw that line in as straight as possible. Oh, did I do it right? No, we didn't do it right. Why not? Yep, it's got to be a dashed line. So let's make those nice dashes. Now notice I went in and just erased, and that's okay. We can just go in and erase spots as well. Now for the purple line, which way do we shade? It's also less than, so I'm going to shade down towards the negative. So all along the bottom side. So now we have to figure out, where do I have both sets of shading? Both sets of shading are on the bottom of each line. So my shaded region, my feasible region where all my solutions are, is where I had both the green and the purple. So unlike our systems of graphing, we have a shaded region, any points in that region. So I'm going to pick just one point that's a yes point. And a yes point would be, since I covered it up, -3, 0. There's an example of a yes point. A no point, right over in here, okay? That's 3, 4. So one point that's clearly inside the shaded region, one point clearly outside the shaded region. Number 2. Number 2, we have two inequalities again, only this time the y is not by itself. So I need to come down and get y by itself. That means I'm going to have to subtract that 4x. Move it to the other side. So I'm going to have 3y greater than -4x minus 6. Now we got to divide by 3. So y is greater than -4/3x minus 2. Because 6 divided by 3 is 2. Let's go ahead and put that on our graph. So our y-intercept's at -2. And we're going to go down 4 and right 3, or up 4 and left 3. Okay, now we need to draw our line. Is it solid? Nope. Let's go ahead and make it dashed. You can tell that's the most missed mistake right there, even by the teachers. Gotta check and see what line I'm drawing. This one's greater than. So greater than goes on top of the curve. So we're going to shade all up above the curve. Alright? Let's go ahead and do the other equation has a similar problem. We're going to have to solve for y first. So I'm going to move the x to the other side. It's going to become negative. Now we're going to divide by that negative 3. Only when we divide by negative, remember you have to flip the inequality symbol. And it changes the sign because negative divided by negative is a positive. Now we're graphing 3 on our y-axis. And then our slope is up 1 over 3. This line is a solid line because it has the line underneath the inequality symbol. And we are going to shade which way? Well, it is a greater than. I said we're going to switch that inequality symbol and then I drew it wrong. It's a greater than, so it's above. Now I need to look and see where do my shadings intersect. So the green and the purple are both above the lines at the top of the graph, so we would shade in everything at the top. Now a yes point would be somewhere in that shading. So we're going to say negative 2, 5. That's up there. And then I could also pick a no point, and I'm just going to make it easy and put 0, 0. Number 3. Number 3 is a little easier because one of the equations is always already in the y equals format. So I go to negative 2 on my y-axis, and I notice it's just a less than symbol, so it's going to be a straight line. Remember, this is a horizontal line. And it's going to be dashed because we don't have that equal to. And then which way do we shade? We shade less than, so that's everywhere below that line. Alright? It doesn't have to be neat on the shading. If you just want to put a few marks just to indicate, that's fine. Now let's look at the second line. The second inequality, we have to solve that. So I have to subtract that 4x, move it to the other side. Remember, anytime there's a whole number, it's over 1. So my y-intercept's at negative 1. And we're going to go down 4 and right 1. This line is going to be a solid line because it has that equal to underneath. And for the shading for this line, it's greater than, so greater than is going to be up where the y positive axis. Okay? Now I shade where both of the other shadings overlap. They overlap in the bottom right hand corner. So that's where we will put our shading. Now let's identify one point that's in the shaded area. So we're going to have one yes point. And let's say 4, negative 4. And one no point. And I'm just going to pick 0, 0 again. 0, 0 is always a good one unless it's on a line. Number 4. Number 4, we get the same problem. Our y's are not first. We need to get them alone. So I'm going to do the first equation. The x plus y greater than equal to 2. You need to subtract that x and move it to the other side. So I'm going to have y greater than equal to negative x plus 2. We'll go ahead and put that on our graph. B is 2. That's the constant. And then my slope is negative 1. So it's going to be down 1 over 1. Down 1 over 1. So we're going to draw in a nice straight line. Maybe straight line. Not doing so good on the straight lines today. Okay? And then which way do we shade? We're shading greater than, so that's going to be above the line. Now let's look at the second equation. Second inequality, what are we doing? Well, we got to get the y by itself. So I have to subtract the 4x. So I'm going to have y greater than or equal to negative 4x minus 1. So my y-intercept's at negative 1. That's where the constant is. And then I'm going to go down 4 over 1. And we're drawing a solid line on this one as well, because it has that inequality with an equal sign. And then which way do we shade? Well, this one's also greater than, so it's shaded on top. So now we gotta look where our shading overlaps. I have both purple and green on the top right-hand corner. Now I can find a yes point and a no point. Remember, any point in the shaded region is a solution, so it qualifies for my yes, it is a solution. And I'm going to pick, we'll go with 3, 4. You could have picked a different point if you wanted to. And my no point, we'll just go with 0, 0. Number 5, we have to write the equations from the lines, or write the inequalities. So I'm going to take the solid line first. What is the y-intercept for the solid line? Well, it's at positive 3. So I know I'm going to have a y, I'm going to have an x, and there's going to be a plus 3 at the end. Now I need to figure out my slope. Notice the slope is going down. So that's going to be a negative. And if I count, it goes 1, 2, so it's down 2, and then right 1. So that would be 2 over 1. Or you could just write it as negative 2. Now let's figure out the inequality symbol. We know it's going to be an equal to, and it's shaded where? Above the line. Above is greater than, so we have greater than, equal to. Easy enough. Let's do the dash line. What is the y-intercept for the dash line? It's at negative 3. So I know I'm going to start with a y, and I'm going to have a negative 3 at the end, behind my x. Now I have to figure out the slope. Well, there's this key point right here where they intersect. How far does it go up? It goes up 1, 2, 3, 4. So it's up 4, and then right 1. It's a positive slope, and we don't have to put the over 1. We can just put the 4. Now, which way is it shaded? This is shaded up as well, because it's attacking. It's over the top of the y-axis, so it's going to be greater than. But the dashed line does not have the equal to, because it is dashed. Number 6. Number 6, we're also writing the equation for the line. We have two different inequalities here. I'm going to start with the one with the highest y-intercept. That y-intercept's at negative 1. So I'm going to have a y, and I know there's going to be an x minus 1. Now I have to figure out what kind of inequality symbol there's going to be and the slope. So I notice the slope is going down. So I know my slope's going to be a negative number. Now as I look, it goes down 1 and right 1. So it's just negative 1. Now did we have to write the negative 1? No. We could have just written the negative sign, because a 1 is understood. So now let's look at the inequality. We know it's going to be an equal to. The question is it greater than or less than? It's shaded above the line at the top of the y, so it's going to be greater than. Easy enough. Now let's go look at the other line. The y-intercept for the second line is at negative 3. So I know I'm going to have an x minus 3. The inequality or equation always starts with y. Now let's figure out our slope. Our slope is going up. Up 1 to the right 1. So it's a positive 1. We don't have to write the 1, so we'll just leave it. Okay? Where's my shading? My shading's above the line. So this is also greater than, and it's also equal to because it is a solid line. Number 7. Now we get into our word problems. These are actually really fun. So we see that we have a carpenter making bookcases. He has 2 sizes, a large and a small. So I'm going to have L for large and S for small. Actually, S's look like 5s in my handwriting, so I'm going to do an M for small. And it's okay to do stuff like that, alright? It takes 6 hours to make a large and 2 hours to make a small. So we know that he's going to spend a minimum amount of 2 hours for a large and 6 hours for, or 2 hours, 2 hours for a small, 6 hours for a large. So my large has to be greater than or equal to 6, and my small has to be greater than or equal to 2. Okay, so there's my large, there's my small. Now let's see what else we got. He can only spend 36 hours a week making bookcases and must make at least 2 of each size. So maybe this inequality shouldn't be the 6, but should actually be a 2 right here, because I need a minimum number of 2. So this is number of bookcases, number of large, number of small. So I need a minimum of 2, and now let's use those hours. So I have 6 large plus 2 small is greater than or equal to. Is it greater than or equal to? No, it says a minimum, right? He can only spend 36. So it has to be less than or equal to 36. He can't spend more than 36 hours. That's his maximum. Now here's the fun part. You have to pick which axis is going to be small, which one's going to be large. I'm going to put the large on the X and the small on the Y. You could do it the other way. If I do that, however, I do need to solve my equation that has all the wonderful variables right here for my letter M. So I'm going to take 2M less than or equal to, I'm going to subtract that 6L to move it to the other side, and now divide everything by 2. So I get negative 3L plus, what's 8? Yeah, it's 18, right? 36 divided by 2 is 18. Now, we can graph things. Yes, we can actually graph it. So let's look. We're going to do 18, right? Well, I'm going to count by 2's on my y-axis because I am not going to take up the whole page here. So I got 2, 4, 6, 8, 10, 12, 14, 16, 18, right up here at the top. That's my 18 mark. Now my slope is negative 3 over 1. You keep it consistent, count by 2's on the x-axis as well. So I can just go down 3 over 1, down 3 over 1, down 3 over 1. That is one of my lines. Now we know we're shading below that line, so just keep that in mind. We're going to shade below the line. Now let's go in and do the L greater than 2 and M greater than 2. So if L is greater than 2, that would be a nice vertical line. And if M is greater than 2, that's going to be a nice horizontal line. Very cool. So my shaded area is actually the little triangular blob right in the middle, because we have to do more than 2 but less than what's on my diagonal. So any answer inside is going to be a solution for this problem. Remember, you cannot have a negative number of bookcases. I know, we're crazy like that, right? They did not ask us to do any kind of cost analysis on this, so this would be my answer, and that's all. Number 8. We're doing an analysis on the hair salon. They schedule appointments for 30 minutes for haircuts and 1 hour for highlights. Okay, so I've got haircuts and highlights. So I'm going to do a C for my haircut and an H for my highlight. Okay? The salon wants to schedule no more than 4 highlights. So that, if it's not more than, that means it is less than. So I can have 4, but I have to have less than that. And they want at least 3 haircuts. So my haircuts has to be greater than or equal to 3. Now let's use that first sentence. It's 30 minutes for a haircut and 1 hour for highlights. So I have 1/2 for the haircut plus 1 for the highlights, and that has to be less than or equal to 8 because they only work 8 hours in a day. Well, H seems like the easiest thing to solve that problem for. So I'm going to put H on my y-axis and C on my x-axis. And I'm going to solve this equation for my H value. So I'm going to subtract the 1/2 C to the other side. So I end up with H less than or equal to 1/2, and it's negative C plus 8. Now this one doesn't have as big a number, so I can count by ones. My y-axis, I'm going to count up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Mark that as 8. So now we go down 1 over 2. That's my slope, down 1 over 2. We can draw a nice solid line in there since it has an equal to. Kind of goes off my graph, but that's okay. Now let's go back and plot the other ones. So haircuts had to be less than 4. Is that right? Less than 4? So haircuts was on the y-axis. So I'm going to come across and do a line at 4. That was highlights. Highlights was less than 4. Haircuts was greater than 3. So I'm going to come in and do a vertical line at 3. Now where is my shading? That's always the tricky part. So if I look, it's more than 3, less than 4, and less than my green line that has the haircuts and the coloring in it. So it's a little trapezoid down here. One side of it looks like a rectangle and it's got that triangle attached to it. Now we don't have to do an analysis on this one, so this would be our answer. We didn't even ask for a yes point and a no point. Number 9. Number 9, we have the International Canine Academy. They raise sled dogs and poodles. So I'm doing D because my S's look too much like 5s. So the number of dogs they can have at most is 20 poodles. So that gives me my first inequality. So my poodles have to be less than or equal to 20. And my sled dogs have to be less than or equal to 15. Okay? They said each poodle eats 2 pounds and each sled dog eats 6 pounds, and they're restricted to 100 pounds of food a day. That gives me an equation with both. So sled dog is 6, so I have 6D, plus, how much does the poodle eat? 2, so 2P, and that's less than or equal to 100, because that's the most food they can have in a day on site. So it's up to you as to whether you make poodles the Y or dogs, sled dogs. I'm going to do my poodles on my Y and my sled dogs on my X. So I'm going to solve my equation that's got both variables for my P. So I got to subtract the dogs over to the other side. So it becomes 2P less than or equal to 6D, and it's negative because it moved to the other side, plus 100. Now let's divide everything by 2. So poodles are less than or equal to negative 6 divided by 2 is negative 3. And then divide 100 by 2 and I get 50. So we're going to count, let's count by tens, right? I know I got that 15. I can make it halfway in between. That's fine. So count by tens. Y-intercepts at 50. So 50 would be right here, 5, 10, 50. And we're going to go down 3 and over 1. You know what? Let's count by 5s. That'll make it easier. Okay, so counting by 5s, I get down 3 and over 1. Awesome. Now, we need to graph our other 2 inequalities. So let's look at my poodles. I have to have more than 20. We counted by 5s. So more than 20. Or is that less than? That's less than. I'm losing it. So we got to go less than 20. And then, for my sled dogs, we want less than 15. Again, we counted by 5s. So we're going less than 15. So I'm going less than 20, less than the green line, less than that 15. So it's almost that square chopped off. Again, another trapezoid. Now some of you may be wondering, why in the world didn't we shade past the axes? I can't have a negative number of dogs. Okay? So there's no negatives. Not a negative number of bookcases, not a negative number of dogs. Make sure you remember that. And we were not asked to do an analysis, so this concludes number 9, and we have one more problem. Number 10. Number 10. Let's see, we got hot sandwiches and cold sandwiches. And they've never sold more than 125. So if I do cold plus hot, that's going to be less than or equal to 125. Okay? Now some days they run out of one, and other days they have leftovers which can't be sold. So past sales indicate there's between 60 and 80 cold sandwiches. Well, the fun part is the cold is sandwiched between 60 and 80, right? Well, that's easy enough to remember. And what about the hot sandwiches? Well, they sell between 40 and 60. So I'm going to go between 40 and 60 for my hot sandwiches. Okay? So now we can put those on the graph. I've made my hot sandwiches the y-axis. And I'm going to count by tens. Yep, count by tens. So, hot sandwiches, y-axis, so I'm going to go 40. So that would be at 4. So there's my 40. And 60 is going to be 2 above it. Okay. My cold sandwiches are what? They're between 60 and 80. So you got to find 6. 2, 3, 4, 5, 6. So there's 60. And there's 80. My lines are not so straight. You can laugh. Okay? Now let's look at that 125. So that would be at 12, right? 10, 11, 12. Okay? So I'm going to come all the way up. And my slope, what is my slope? Oh, wow, we forgot to solve that. Let's go down and solve that. Need to solve this equation for h. So that would be h less than or equal to negative c plus 125. So glad we solved that. Now we're going to go down 1 and over 1. Nice and neat like. Don't do it the way I'm doing it. Nice and neat. Down 1, over 1. Go right through the diagonals. Okay. Alrighty then. Okay, so the last step is to go in and do the shading. So where are we shading? Well, it's between my two cold lines, between my two hot lines, which was originally a little box. Only now we've chopped the corner off that box. So the number of sandwiches I can sell and make a profit is going to be in between any combination inside that box. This concludes our practice for solving inequalities.